Good morning, students. Today we will continue with our chapter Trigonometric Functions exercise 3.3, and we have done till sum number 21. Now we will discuss sum number 23 here. For sum is given tan 4x is equals to 4 tan x into 1 minus tan square x divided by 1 minus 6 tan square x tan raised to power 4x. Okay, so here in the RHS, if you notice, we have tan power 1x also, tan raised to power 2 also, tan raised to power 4 also. But in the left hand side we have only tan 4x, right? And we have one formula also. The formula is tan 2a. It is 2 tan a upon 1 minus tan square a. So here whatever a angle is there, here if double angle is, that's angle A is coming here, and similarly here A angle is coming. So what we can do, we will start with the left hand side and we will apply the formula, right? Left hand side is tan raised to tan 4x, and it can be written as tan 2 of 2x, right? Tan 4x can be written as tan 2 of 2x. Now what is this? This is our A if I compare it with our formula. Okay, now we can apply this formula tan 2a here. 2 will remain as such, the value of a is 2x, so this will become equals to 2 tan a is 2x divided by 1 minus tan square a is 2x. Now what is the required part in the right hand side? Angle is x everywhere. In the left hand side we started with angle 4x, but everywhere we want angle x only. After the application of formula, now we are getting angle 2x. Okay, that means further we have to divide the angle by 2. So this tan 2x, once again same formula I will apply. This 2 will remain as such, and tan 2x, what is the formula? 2 tan x divided by 1 minus tan square x whole divided by 1 minus tan 2x, again 2 tan x divided by 1 minus tan square x whole square. So here in this part again we have applied the formula. Here also we have applied the formula, tan 2x, and here tan 2x whole square. So formula, same formula has been applied how many times? 3 times. First we have applied here when tan 2a, a is 2x. Then here also we applied the formula tan 2x, same, a is now x, and this is how we are getting. Now the next thing is only to simplify. It will be 4 tan x divided by 1 minus tan square x whole divided by, here we are going to take LCM, 1 minus tan square x whole square minus 2 tan x square, it will give you 4 tan square x whole divided by 1 minus tan square x whole square. Okay, so here square will get open, this and these two terms will get cancelled, one term will go to the numerator. So what is left? It is 4 tan x. Here we will have 1 minus tan square x divided by 1 minus tan square x can be written as 1 plus tan raised to power 4x minus 2 tan square x, and this minus 4 tan square x will come as such. Now I think the sum is done. Minus 4 minus 2 minus 6 plus tan raised to power 4, and this is what we were supposed to prove, right? So we will say that this thing is coming equal to 4 tan x into 1 minus tan square x whole divided by 1 minus 6 tan square x plus tan raised to power 4x, and this is nothing else but this is our RHS. So this is how the sum will be done. First of all, first thing we are starting with the left hand side. Tan 4x we are writing tan 2 of 2x, then tan 2a formula is applied, and when we have applied this formula, again I am getting tan 2x here, tan square of 2x here. So once again same formula, tan 2a in the numerator, tan 2a in the denominator. Then we are just solving it, simplifying, and straightforward our answer is coming. Okay, so this was sum number 23. Now once more sum we have, and let us do now sum number 24 and sum number 25. Any one sum we will discuss. Let us discuss sum number 25. 24th you people will do same way. You need sin square x cos square x function. Accordingly we will apply the identity. So here we have cos 6x equals to 32, cos raised to power 6x minus 48, cos raised to power 4x plus 18, cos square x minus 1. This is our statement. Now angle is 6x here, and in this right hand side everywhere angle is x only, but we are having different powers of the function. It means we have to break this angle 6x, right? So it is very clear, then we have to start with the left hand side. So left hand side is cos 6x. Now this 6x can be written as 2 into 3x also, and it can also be written as 3 into 2x. So anyhow you can start. If I write down cos 3 of 2x, now this 2x is actually a, cos 3a. We have the formula for cos 3a. What is the formula for cos 3a? We will mention the formula here. We will write down cos 3a is equals to 4 cos cube a minus 3 cos a. This is our formula on page number 68 given. So let us apply this formula. In our sum, the value of a is 2x. Okay, so according to the formula, what we will get, cos of 6x will be equals to cos 3a. A is 2x, so it will become 4 cos cube a is 2x minus 3 cos a is 2x. Okay, so now angle from 6x, what we got, 2x. Okay, so I am rewriting this thing as cos 2x whole cube can be written as, and this is same 3 times cos 2x. Now cos 2x formula also we have, right? We have cos 2a is equals to, now if you remember cos 2a, we have 4 formulas. One is terms of cos and sine, that is cos square x minus sine square x. The other is in terms of sine only, it is 1 minus 2 sine square x. Then one formula is terms of cos only, that is cos 2 cos square x minus 1. And the last formula is in terms of tan, and what is that? It is 1 minus tan square x upon 1 plus tan square x, right? But we don't need the answer in terms of tan, we don't need the answer in terms of sine, we only want cos function here. So which formula we will apply? Which is having only cos. So cos 2a, which formula we are going to apply? It will be 2 cos square a minus 1. So that formula if I apply, cos 2a angle is getting converted into a only. That means if I apply this formula in this term, cos 2x and cos 2x, the angle 2x will get converted into x. So our purpose will be solved. So let us apply. It will be 4 times, now cos 2x is 2 cos square x minus 1 whole cube minus 3 as such. Cos 2x is 2 cos square x minus 1. Now we have to just open the brackets, a minus b whole cube and this as such. So here 4 will remain. A minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. So it will be 8 cos square x whole cube. So it will become cos raised to power 6x. This minus 1 will remain as such, minus 3a square b. A square is 4 cos raised to power 4 into 3 minus 12 cos raised to power 4x and then plus 3 into 2 6 cos square x as such minus 6 cos square x, okay, and plus 3. So let us see what we are getting. 8 into 4 32 cos raised to power 6x minus 4 minus 48 cos raised to power 4x plus 24 cos square x minus 6 cos square x, and the last term is plus 3. The sum is done. 32 cos raised to power 6x as such, then minus 48 cos raised to power 4x plus 24 minus 6, it will be plus 18 cos square x minus 4 plus 3, that is minus 1. So this is how our sum is done. This is the RHS which we're supposed to prove. So what we have done here, we have applied the formula first of all for cos 3a. If you start as with cos 2a, that means instead of writing cos 6x as cos 3 into 2x, you can even write cos 2 of 3x. Then cos 2a formula you will apply and then cos 3a formula you will apply. But here if I start with cos 3a, so our sum will go like this, and 2 times here cos 2x formula we will apply. So this is the formula and these two formulas are applied. Then we are just opening the brackets, multiplying, solving, and your answer is there. Now you people can do easily sum number 24, and cos 4x is there. So cos 4x can be written as cos 2 into 2x. Now you have to think you need sine square also, cos square also, and these two functions are in product. So accordingly you will apply the formula. This was all about exercise 3.3. Now we will discuss few sums of exercise 3.4 and we will move to the next page. So the next topic that we are going to start, it is trigonometric equations, and this is important topic, okay. Trigonometric equations. Now we know what is the equation. Equation means any expression is there, any polynomial can be there, and if that polynomial is having the sign of equality, right? If any polynomial is written here, sign of equality is there, either it is 0 or any other constant is there, or even some other function can also be there. And when this thing is there, means any expression involving the sign of equality is called equation. We know if it is the polynomial is quadratic, I say then it's quadratic equation. And when we solve the equation, definitely equation means we have to solve it, and when we solve we are always finding the value of the unknown x. If it is quadratic, we will get 2 solutions of x. If I am solving cubic equation, I will get 3 solutions, that means 3 values of x. So whenever we solve the equation, generally we are finding the value of the unknown. We have learned how to solve even the system of equations. System means when I am solving 2 equations or 3 equations simultaneously. And now if I solve 2 equations, 2 linear equations, you people have done solving the system of linear equations. If 2 linear equations are there, like I have ax plus b is equals to c and dx plus e is equals to f, then what do we do? Or let me make it more clear. If I have equations, definitely when 2 equations are there, there will be 2 variables, and these 2 variables we always find. So solving equation means solving the value of the unknown. Now we will talk about trigonometric equations. Trigonometric equations means the equations involving trigonometric functions, equations involving trigonometric functions of a variable are called trigonometric equations. Okay, so the equations which are having trigonometric functions of a variable, definitely whenever we write down trigonometric function, it will have some angle. Now angle will be some variable, okay, like it will be x, y, theta, whatever it is. So that theta or x or y we will calculate. Okay, so when we are solving trigonometric equations, again same thing, we will be calculating the value of the unknown, right? And that unknown x or y or theta is actually the angle of that particular trigo function. Okay, so here again we will have 2 types of solution. The first solution, whenever I solve the equation, for example, let me take the example first, and I have taken, let us take the simple example, like sin x is equals to 1 by 2. Sin x is equals to 1 by 2. Now the question, if it is solve or if it is find the principal solution, before introducing to the term principal solution, if I simply ask like find the solution or solve it, when the question comes solve it, that means I have to find the value of the unknown. Now sin x is equals to 1 by 2. Now this 1 by 2 I have to check when it is coming 1 by 2 in terms of sine. That means for what angle of sine, the answer will be 1 by 2. And I hope everybody knows that sine pi by 6, that means sine 30 degree is 1 by 2. So I will write down here, we know that sine pi by 6 is equals to 1 by 2. Therefore, sin x will be equals to sin pi by 6. Now, there one thing we have to take care of, whatever function is there in the left hand side, if it is sin x, the right hand side value I have to find in terms of sine only. So 1 by 2, that means I will find for what angle of sine I am getting 1 by 2. So sin pi by 6 we know. Now sin x is equals to sin pi by 6, if it means I can say the value of x will be pi by 6. So this is the solution. That means if I have x as pi by 6, then my answer is there. And what is the answer? 1 by 2, right? Now here we will have 2 types of solution. This is solution, definitely this is our solution, but what kind of solution it will be, this is called principal solution. This is called principal solution. And the other solution also we will have, that will be called general solution. Now general solution means general solution will have n integer. General solution will be written in terms of n, that will be integer. That means by putting different values of that n, I can have different principal solutions. Okay, but yes, there are again few restrictions on the principal solution. What is that? So let me take you to the now restrictions. What are the restrictions on the principal solution? So our principal solution p dot s always lie in where? Principal solution always will be here, greater than or equal to 0 and less than, only less than 2 pi. Our principal solution always should be greater than or equal to 0. That means principal solution can't be negative, and it will always be less than 2 pi. I can't have any angle or any solution which is more than 2 pi or even equal to 2 pi as the principal solution. Remember. And general solution, once one principal solution is done, I can always write down the general solution. So we have here three standard results. Okay, and we will use the three standard results to write down the general solution. What are these three general results? Let me write down. We will be just memorizing these three solutions only. There is no need of the proof. So the first is for any real numbers x and y. Wait. Yes. For any real numbers x and y, sine x equals to sine y implies. That means if I have sine x equals to sine y, the same example if I consider, in the previous example we wrote the sum was sine x is equals to 1 by 2, and 1 by 2 we wrote sine x is equals to sine pi by 6. So x is x only, that is unknown. This y we will be knowing by our calculation part, and here in the example y was pi by 6. So if sine x is equals to sine y implies x will be equals to n pi plus minus 1 raised to power n into y, where this n will belong to set of integers. So by this thing I can write down my general solution, right? So how it is coming? If I take the example, what was the example? Example was sine x is equals to 1 by 2, and this 1 by 2 we wrote as sine pi by 6. So sine x is equals to sine pi by 6. Now sine x is there. The value of y in our sum is pi by 6. Okay, so the general solution will be x is equals to n pi plus minus 1 raised to power n into y. The y value is pi by 6, and definitely n belongs to set of integers. We have to specify. This will be our general solution. Now by putting different values of n, 0, 1, 2, 3, so on, I can get my principal solution, right? And now if I say n is equal to 0, if I say n is equal to 0, then what is x coming? It will be 0 plus something power 0 into pi by 6. So the first principal solution is pi by 6, that we know. And now if I put n equals to 1, then x will be equals to pi minus pi by 6, because minus 1 raised to power 1 will be minus pi minus pi by 6, it will be equals to 5 pi by 6. So this is our second principal solution. Okay, now if I put n is equal to 2, then x is equals to 2 pi plus minus 1 raised to power 2 into pi by 6. So what is happening here? It will be 2 pi plus pi by 6. Now 2 pi plus pi by 6, it is more than 2 pi. So this can't be the principal solution, because what is the restriction? Principal solution is always less than 2 pi. I can't have the principal solution more than 2 pi. So this is how we will calculate the general solution, and from the general solution I can have principal solution. So here what is the conclusion? I can't have 4, 5, 6 principal solutions like that. 2 principal solutions or at the most 3 can be there, but not many principal solutions we will be having. Okay, this is our first theorem based on which we will be doing exercise 3.4. The next theorem is for any real numbers x and y. Now if I have cos x equals to cos y, if we have cos x equals to cos y, then implies x will be equals to n pi sorry 2n pi plus minus y, again where n belongs to set of integers. So 2n pi plus minus y, where n will belong to set of integers. This will be the result for if I have cos x equals to cos y kind of situation. This is our second theorem for the chapter. Okay, so the first theorem, if sin x equals to sin y, then x will be n pi plus minus 1 raised to n y. If I have cos x equals to cos y, then x will be 2n pi plus minus y, where n belongs to integer. And one last theorem is also there, that is in terms of tan. And what is that? Theorem number 3. It is given if x and y are not odd multiples of pi by 2, then I hope this statement is clear why we are not taking x and y as the odd multiples of pi by 2, because for odd multiples of pi by 2 tan function is not defined. So we have to be specific that x and y should not be odd multiples of pi by 2. So if I have tan x equals to tan y, then it implies x will be equals to n pi plus y, where again n belongs to set of integers. Now x and y should not be multiples of pi by 2, odd multiples of pi by 2. And if this is the case, it can be pi by 6, pi by 3, okay, pi, but not pi by 2, 3 pi by 2, 5 pi by 2, like that. So x will be equals to n pi plus y. So these three theorems are giving the general solution for sine, cos and tan. It means they are applicable to their reciprocal functions also, cosecant, secant and cot respectively. Okay, now let us do one or two sums for that part also. Exercise 3.4, we will discuss one or two sums only so that you people can understand the concept. Okay, so here we have exercise 3.4. we have here find the principal and general solution of the following. So both the things we have to find. The first is given tan x is equals to root 3. Now we have to see at what angle tan is giving us root 3, right? When do we get root 3 by 2 for sine? It is pi by 3, that means 60 degree. So we will write down, we know that tan pi by 3 is equals to root 3. Okay, we know that tan pi by 3 is equal to root 3. So we have here tan x will be equals to tan pi by 3. Tan x is equals to tan pi by 3. So this is actually our y according to this theorem. Okay, if tan x is equals to tan pi by 3, so first of all we will write down the general solution. What will be general solution? It will be x is equals to n pi plus y. What is y here? Pi by 3, where n belongs to set of integers. So this is our general solution. Once I know the angle, right, straightforward that angle has come here, x is equals to n pi plus pi by 3. This is the general solution. Now the principal solution, if I have to find, first principal solution will be that angle itself which we have calculated, so it will be pi by 3. And the second general solution you can calculate by putting different values of n. So this pi by 3 is coming when n is 0, and when I put n equals to 1 here, pi plus pi by 3, what will be that? Pi plus pi by 3, it will be 4 pi by 3. I can't put here negative value of n, because if I put minus 1, minus pi plus pi by 3 will be minus 2 pi by 3. But the thing is, principal solution can't be negative. Okay, now if I put n equals to 2, the principal solution will become more than 2 pi, because 2 pi plus pi by 3, 7 pi by 3. So that is more than 2 pi, not possible. So our general solution will be this, and the principal solution will be these two angles. So this is how we will do, right? I hope you people understood the concept, and you people can do first 4 sums of exercise 3.4. okay, so homework is sum number 1 is already done of exercise 3.4. clear? And if any doubt is there, you can ask your doubts. Otherwise you people can do the homework sums. Thank you, students.